Hello, my name is Artur Pilipczuk. I'm representing Mostostal Zabrze, one of the subsidiary firms from Mostostal Zabrze Group. I'm the second person that is not a developer, software engineer in this room. I'm also not an engineer at all because my primary background is business management and with the focus on logistics. But this was first 8 years of my career. Then I started working for Mostostal, and I was working for different companies in our group on different positions. For some time, I was administering our ERP system. So I know a little bit about SQL and other data-related technologies, but I'm not formally educated in that area. So I will start with a short introduction to Mostostal Zabrze and specifically to the company Mostostal Zabrze Realizacje Przemysłowe, which I'm representing. And then I will talk about the tools and techniques we are using in preparing plans for the construction works. Then I will talk a little bit about the reporting workflow where we are taking data from. And then I will try to show some I can call it in Polish, we'll say a lot problems, and other nations prefer to say issues with the 3D models, what can go not the way it was intended to. So Mostostal Zabrze was founded in 1945, so it's quite a long time. Some key dates, I think it's Mostostal acquired Mostostal Zabrze Biprobchód, so design office. Next, the company dedicated to civil works. And in 2018, there was huge restructure because all of the activities related to project management was moved to the company I'm working for right now. 78 years on the market, 8 companies, 1,650 employees, and over 600 projects in the last 5 years. And a couple words about my company. We are located with the headquarters in Gliwice. We've got 2 workshops in Częstochowa and Kędzierzyn-Koźle and 1 technical office in Germany. We are making projects in all of Europe. In the past, we were also present in South Africa, Libya, Iran, but we are not focused on this right now. These are the labels of our main customers, and we are focused on long relationship with the customer because we are now well prepared to adjust to their requirements. And there is short, I will quickly go through our selected projects because I'm going to talk about the 3D models, which I cannot show you because of NDA, but I can present you the picture of the project from our customer web page. So here you can see the project in in Schwarzheide in Germany, and we were responsible for mechanical installations of piping equipment and the steel structure on the second building. Here's some short summary of the project: 5,500 tons of steel and lots of piping, 80,000 dia inches. There is the second project for our client BASF. There is a project with big lifts we are also doing. And this is in Płock. The biggest column was 200 tons of steel and 70 meters long. We are also doing works in the steel works. Here is information about the heat recovery system, the modernization of blast furnace. This was a really huge project in short time. And now projects from engineering and environmental, municipal solid waste disposal plant in Targówek in Warsaw, and another very complicated project because everything was done inside the building. We're changing part of the channels in the Heilbronn power plant. In other site, I will quickly go through it because I don't want to focus on the projects we did, but behind each of the projects there is a 3D model which we want to use to help us the planning process, and it all began because of the problems. We had, I think it was 10 or 12 years ago, we had a problem on the biggest piping project in our history. There was lack of information. We didn't have any databases of information on what is the scope of work. It was all given to us in PDF drawings, so it was not easy to gather all the data and to make some planning. And that's why to improve this process, Mosostal invested into IT tools to streamline the planning. First, we invested in Hexagon's Spoolgen. This is software to facilitate pipe spooling. Navis works, and with the iConstruct add-on, I will talk a little bit about it later. And we developed some homemade tools to extract and process the data from the information we are given by the client. And finally, we invested into Astapar project. Software, I think the most popular on the market is the Primavera, but Asta, in my opinion, has got even better possibilities, and also it's got the 4D module. It used to be called BIM because we can attach the 3D model in IFC format to this time schedule and present how the site will look at different stages of construction. So it all starts during the bidding phase. Our clients provide us lots of data about the piping scope, but usually this is consolidated into one big numbers for the whole project. But to prepare detailed schedule, which is very important for us at the bidding stage, we have to divide it into some smaller chunks of data, like how many pipes we have to install in that building, how many pipes on that pipe rack, what is the number of equipments, where it's located, etc. We are trying to look for that information inside the 3D models. And that's why we developed the way how to extract the data from 3D models. And in that way, we cross-verify the information provided by the client. For one of the projects, we knew from the 3D model that the number of pipes will be 30% more than they gave us information in the Excel spreadsheet. So we were prepared to make more than they were planning. And using all this data, we can create a detailed time schedule, divide it into smaller chunks, and then better cooperate with the client and show them that we cannot do everything in one day. In our business, we are mostly receiving 3D models in NWD format, so this is native Navisworks format. The IFC files are really rare. Probably this is because of the size of the files. The biggest 3D model in Navisworks format I received was 2 gigabytes. So in IFC it would be, I don't know, 50, 100 maybe. So sometimes these projects are really big. The second thing I have to mention, we are not general contractor on the site. We are the subcontractor, but even as a subcontractor, we are working on really big projects, like 50 million euro worth of piping. So this is huge, and the problem is that as a subcontractor, we are coming to the project at really advanced stage of the design. So we cannot influence the design process, what kind of data we are receiving, how it's structured, and that's why we focused on being really flexible to work on what we've got, not to expect our client to change anything, because usually this is too late, they are behind the schedule, and they already paid for the design and they don't want to invest anything more. So we are using different tools like Properties Plus. This is a free add-on for Navisworks to export the data, and we are using then Excel with Power Query to clean the data and to prepare some useful insights. After winning the contract, we are receiving usually much more of the data, and for the steel structure, usually if we have to install the steel, we also fabricating this in our workshop, and we hired the designer company with which we have already agreed standards, how they need to produce the 3D models with all the data we need. So this is easy part. For piping scope, this is really complicated because there is lots of data. Project can have like 2,000 pipelines. Each has to be verified, divided into spools. That's why we are using Spoolgen for that, and we are receiving from our clients PCF or IDF files, which is standard in the business for piping scope. And this is done internally, the whole spooling process. Erection equipment, this is different topic because usually there are some drawings, some erection manuals and other things, and 3D model is just to judge if we can fit inside the area where the equipment needs to be installed, or we have to think about some special solutions. So I will talk now a little bit about the Spoolgen. Using Spoolgen gives us first advantage. We've got all the bill of materials or MTO immediately after receiving the files. We can easily divide the spools into spools which need to be only that big that can fit into the truck, and also to be possible to install on the construction site. And we are using also this tool to create 3D DWG, so AutoCAD's drawings, which we can use to recreate and present how each spools looks like in 3D model. This is example maybe not seen, but this is human readable format of presenting how the pipeline is built. We have got some Python scripts that we are adding some information to the pipeline, like we are numbering each bolted joint, its support, so the information about the joint number is printed on the isometric. And during the reporting, people who is looking at the drawing and has to report that the work was done, knows exactly which one is which. We are also automatically creating 3D models with iConstruct to give the person responsible for the installation on site to judge if this proposed spooling is good enough to be installed and to create some workflow on checking and reporting the whole process. So this is how it looks like from Spoolgen. We are exporting this pipeline to DWG file. Then we import it into Navisworks. Then using the integrator tool, we are adding some information to be able to recreate the 3D model in the form we need. So this is how this file looks. This AutoCAD file looks in Navisworks right after the import. So you can see all the details about each piece of pipeline. This is a weld. This is also a weld. This is piece of pipe. This is gasket. So lots of details that are not needed at the stage of installation, erection process. That's why we are using iConstruct to recreate this whole 3D model to be divided into erection parts and then the spools. Spool number one, this one is selected, so we can see here this red part, that this is how it will look when the spool will come to the construction site. This is also very time-consuming process. That's why we are using another tool from iConstruct. It's called BeamFlow, and this is some kind of scripting tool that we can automatically import files in a folder. Then the several actions are being done to add some data to the project, and then it recreates the 3D model, attach this to the model of the whole site, and then creates the views to be able to check the routing of each pipeline and see if this is correctly splitted into spools. And we are doing all of this to be able to export this Navisworks model into IFC format, because Astapile project only accepts 3D models in IFC files, and then we are able to prepare such simulation of the construction process. Maybe it's not impressive because this is very small model we are providing for the challenge today. But if the site is really big, this looks really impressive, and this is also very helpful because we can see that we are not starting erection something on the level 2 if the level 2 is still does not exist. This is not easy to look in the huge, I don't know, 3,000 lines of time schedule to check if everything has got really good connection to create correct erection sequence. But if you see this building in the 3D model, you can easily spot some discrepancies or gaps. And after creating this plan, we are using another tool to gather the data from the construction site. We are looking for some not expensive and elastic tool, and we found a company in Kraków which is selling a Amagi system. This is a facility management system, and we are using this to create all the assets on the site. An asset can be pipeline, equipment installed, some part of steel structure, and we can create different reporting tools, and we can track the progress divided into some smaller steps. So for the process of pipe spooling, we can track when the isometric was received by us, when the spooling was done, was it correct, was the prefabrication started, finished, was delivered to the site, etc. And we know who reported it and when, and all this data is stored in the database, and we are using Excel as our main reporting tool in our company and for our clients, and we are connecting to the database, and we are presenting the progress on different levels depending on the needs. Also, progress of the project needs to be presented inside the time schedule. In Primavera, this is very labor-intensive task because you have to manage it on each task independently. I was trying to automate this, but this was really difficult. Here we can first use some simple copy-paste techniques to update the time schedule, or even because the Astapel project has got VBA built in, so we can connect the database directly and update the status of each task just based on the data from the database. Also, if there is lots of pieces of equipment, pipelines in the project, we can use VBA to create these objects in Astapel project. So create some selection sets, setting all the parts of the pipeline as a one object and connect it to the correct task. And this allows us also the data from Amagi to contact it, to make connection to the database and use the data to present the status of work inside Navisworks. Here we can see with the colors, maybe it's not visible, but each color means a different stage of construction works. And here, we are also using this. This is a tool called audit tool, and this allows us to create different definitions for each scope of work and present the current status of on-site. This is very helpful because, for example, if we planned to work in one area and this is not possible because there is some clash with other subcontractor, we can easily check in 3D model which part of the construction still, for example, we've got from on the other side of the building, for example, and then move our forces to start other work. So now quickly about the problems in the 3D model. First one, this is excessive graphical details. Here you can see some details from the 3D models we received. The first one is the part of the electric motor, and it consists of 250,000 polygons. So if you try to export it to IFC format, it won't work. On the other picture, here is some kind of mesh of the fence, and it consists of 50,000 polygons. So this is huge, and this makes this work unmanageable. Now we are testing to use Blender to simplify the graphics, and maybe this will help us to go. And the size of the file is important because we wanted the 3D models to be available on mobile devices and in the web browsers. And here is an example of showing the 3D model on the mobile device, and here is in the web browser. In the future, it will allow us to give the people working on site to report the finalization of one of the steps just by clicking on the 3D model. We are using also some tools to recreate or clean the data inside the 3D model. I got no time, so I will go quickly through this. We can add some custom data to the 3D models, like location and sizes, area. This may be useful on the bidding stage. And also, we've got some problems with, I would say, not correct the creation of the data. Here you've got one of the objects in 3D model, and each property of this element is named by the number of the pipeline it's connected to, because this is part of the pipe. So we cannot look for it, even make a query inside the 3D model, because each property is unique inside the 3D model. So we've got a custom-made tool just to clean these properties and to add the data. And we've got the tools that can create some insights from the 3D model by dividing it into different parts just by making query for one of the properties. So here you've got different kind of steel structure just by making simple query from the 3D model. That's all. Thank you. Maybe.
Any questions?
Okay, so thank you very much.